Hello, and in this video we're going to be looking at quadratic models again. Last one we did an area formula, or a quadratic of an area. This time we're going to be looking at a path of a projectile through the space. Well, let's look at this problem. A projectile is fired from a cliff of 200 feet into the above a water, inclination of 45 degrees from the horizontal with a muzzle velocity of 50 feet per second. The height h of the projectile is given by this quadratic model. Well, we can see here's where the 200 comes into play, the 200 feet above the water. The 50 feet per second has to do with this, I believe, the 50 in the denominator. Okay, if we were to look at a picture of this, we would have a cliff that we're standing upon. We're going to fire this projectile into the air at an angle of 45 degrees. It's going to go up and then back down and hit the water, which is down here, hopefully. All right, so we have an angle of 45 here. From the horizon, we're 200 feet up. So we initially start with a value of 200. If we were to put 0 in here, we would get 200. So we're initially at 200 feet above the water. It's going to go up into the air and then back down. So this is a quadratic model. It follows the path of a parabola. So we're going to use this model to answer some questions. All right, so our first question is, at what horizontal distance from the face of the cliff is the height of the projectile a maximum? So what we're doing here is we're looking for this value up here that's a maximum value. All right, so as before, we're going to use the formula for the vertex. So our x of our vertex is the formula minus b over 2a. So we're going to use that to figure out the x value of the vertex. That won't tell us the height, but that'll tell us the x value where that height is the maximum. So if we're looking at this, this value right here is b, and this value right here is a, and this value here is c. So the value in front here is b, so we're going to have, for this value, we're going to have minus 1 for b over negative 32 over 50 squared, all squared. So we're going to take our calculator and figure that number out. It's going to be an x value. It should be an x value. If we do this, this means reciprocal. Let's do a little bit of work before we plug it into our calculator. This means reciprocal of our solution. And, oh, this is not squared down here. This is 2 times a, sorry. And the formula, I'm squaring that when this is actually 2a down on the bottom. Okay, so we're going to take this minus b over 2a and we're going to compute that value. Well, this is just the reciprocal of this value. So if we simplify this a little bit, we're going to have negative 1 over negative 64 over 50 squared, because this is 2 over 1, and when we multiply 2 times 32, we get negative 64. Now, this means reciprocal, so we're going to take the reciprocal of this value, so we're going to get 50 squared over 64, and we're going to have 2 negatives here, so we're going to have a positive answer there. Okay, so that's 2500 over 64, so I'm going to use our calculator to get an estimate of this value. We're just waiting for the calculator a little bit. This is the function. I'm going to graph it as well. We're going to see this projectile motion and see if we can find the maximum and compare it to what we found here with minus b over 2a. So, all right, so 2,500 divided by 64. We get 39, just a little more than 39 here. So 39.0625 feet, if this is in feet. Is this in feet? Yes. So approximately 39 point, oops, let's find that, 0625 0625 feet. Okay, so that's our value. So let's just check that on the calculator and make sure we get that same value out of the calculator. We have the graph, as I said, I typed it in, negative 32x squared divided by 50 squared plus x plus 200. I'm going to set our window. We don't really need any negative values here. I am going to leave a -1 in there so that we have a little bit of space between the axis and the value. And then x is the maximum. It says we want to at least go 39 here. So we're going to go to, let's say we're going to go to 100. And we're going to count by tens for a scale. All right, we don't know how high it is, so let's try. We're going to put in a -1 here. We know it's at least 200 here, so it's got to be above 200. So let's just put in 500 here, and we'll go by 50. We'll look at the graph, see if we can see the whole parabola here. Graph. Okay, so it doesn't look like it went up that much, so we could have probably went less than 500 here. So if we choose our window here, let's make this 300. Let's try 300. See if you can see a little bit more of the curve. There we go. It still doesn't even look like it went up to 250 there. So if we want, we can change this to, it doesn't look like it went up 250. We want to see more of a parabola shape, we can just change our Y max and get more of a shape of a parabola. Okay, so it looks like the maximum somewhere in here. So let's find that by using second calculate. We're going to find the maximum, which is number 4. Enter. It says left bound. Let's go to the left where it looks like it's going down a little bit on the left hand side. Okay, we push enter. Right bound, we're going to move to the right hand side of this almost flat line, it seems. Enter, and then guess. I'm going to guess somewhere in the middle of that. Enter. So it looks like we came out really close, 39.062486 and 219.5. All right, so they're saying 219.5. So let's plug in this value to our equation and see if we get 219.5 for our maximum height. This is the horizontal distance. The second question here is finding the maximum height, which is what we're working on right now. So our answer to horizontal distance is 39.625. That's the answer to this question. Now we're working on maximum height. Maximum height, we need to plug that value back in to the equation. So we're going to have h of 39.0625 equals -32. 39.0625 squared over 50 squared plus 39.0625 plus 200. So this is what we would want to plug in to figure out this value. We're hoping that the value is close to the answer that we got here in our calculator, 219.5. So let's just use our calculator here to test this out. -32 times 39.0625 0.0625 squared divided by 50 squared plus 39.0625 plus 200. So we're just evaluating this, and we get this very similar answer here. We're going to get 219.53. 125 feet. So approximately 219.5 for this maximum height. 219.5 feet. All right, the next question was, when did it strike the water? What horizontal distance from the face of the cliff will a projectile strike the water? So we're looking at when this function up here is going to be equal to 0. So part C here is we're going to take 0 and set that equal to the thing. This is part C. We want the striking the water would be a height of some x value equaling 0. So we're going to set the equal to 0. We're going to use our equation, and we will plug that in up here. 0 equals negative 32 over 50 squared, x squared plus x plus 200. Now we're not going to be able to factor this, so we're going to use the quadratic formula. So x is equal to minus 1 plus or minus the square root of 1 squared minus 4 times a, which is negative 32 over 50 squared, times c, which is 200, all over 2 times a. All right, now I'm going to use my calculator to see if I can get the answer to this one and find that distance, which is that's going to occur. Now, on this equation, since the denominator here is negative, we're going to want the negative answer up here. We're going to get a positive answer if we use a plus here, but we're going to want the negative answer here because we're going to divide by a negative value so that we get a positive answer out of this. So let's just, I'm going to do the square root first. So square root of 1 squared, which is 1, minus 4 times negative 32 divided by 50 squared times 200 is going to equal 3.35. Okay, then we're going to say we want the negative of that, so we're going to do minus 1 minus our answer, which is 3.325. We're going to get this answer, and then we're going to divide that by negative 32. I'm going to put this in parentheses because it is a fraction. We want to divide by the whole fraction, divided by 50 squared. Okay, so that's going to give me a value of 340. So approximately for x here, x is going to be approximately 340 feet. So it's going to hit the ground around 340 feet. Let's just double check that on our calculator. So we had a graph, besides checking it with the numbers here, but we're going to check it on our calculator here. All right. Okay, we'll do that on the next video. We'll move on.